Hello everyone and welcome back to Arctic Retro. And today I'm gonna build something for this little guy. It's the ZX Spectrum. And I have the machine up and running already. This very red machine I built myself in a video a couple of years ago. All from modern parts, even the CPU, but no, you don't get the CPU anymore, the Z80. But still it functions exactly like the real ZX Spectrum, but it has a little bit more modern video output. But hey, you said sound card. The ZX Spectrum doesn't need a sound card. It has a small speaker built in and it can do sort of beeps. Yes, it can do. But you can actually make some sound hardware for this if you want to. And I recently saw a video on YouTube by 8-Bit Show and Tell where he showed off two expansion PCBs for the ZX Spectrum that could play music, and yeah, I just wanted to build that myself.
Hi, it's Robin. One more hurried, unscripted video.
So I just wanted to build the same myself and test it out, and that's what I'm gonna do today. And the thing I'm talking about is actually a couple of projects you find on the webpage of Factor of Matt. Matt is the creator of the Desk Test, and they also have some stuff for the Specky. And here you find a couple of projects to try out, and here's the ZX Sound cards. And that was actually a couple of articles from magazines back in the day where you can actually build these yourself. But back then it wasn't so easy to make PCBs. You had to etch them yourself, or it would become very expensive. But nowadays you have PCBWay, which is my sponsor, and I got my PCBs from them. Let me just make a quick stop here to thank my sponsor, PCBWay. PCBWay produces PCBs, but they also do a lot of other cool services. They have supported this channel for several years, and without them I don't know if I could have a YouTube channel at all. As you can see, very nice quality, and just $10 for 10 PCBs. Besides getting an instant quote for PCBs, they also do services like 3D printing, CNC machining, and PCB assembly. Also check out their PCBWay mascot design contest for 3D printing if you want to participate and win some prizes. PCBWay takes care of all your hobbyist needs, so go ahead and visit PCBWay.com right now. The rest of the parts I bought myself, partly from the bill of materials I found on this page. Both these projects or cards, they use the AY-891X Sound chip that you will find in a lot of retro computers from back in the day. Even the later Sinclair's machines had it, but not the original ZX Spectrum. It doesn't have a sound chip. If you go to the GitHub repository of Factor of Matt, you find the Sinclair ZX PSG, and here's the explanation you need, the various circuit diagrams, and actually the software you need to use those cards. So these projects were from two different electronics magazines back in the day. One was from Hobby Electronics and the other one was from Your Computer. So here is the Hobby Electronics ZX sound card, and this is the circuit diagram and board layout and all the components you need. The other one is from Your Computer, and it's called Mozart Lives. Looks a bit similar, but it's quite different. It uses the AY-891X sound chip with a couple of logic chips and capacitors and resistors, and there's a LM386 amplifier there. So not a lot. The other, the ZX Sound, yeah, also AY-38912 on that one. Couple of logic chips, and also an amplifier chip and a couple of capacitors. So seems kind of simple, should be easy to build. So before I continue, I'm just gonna tell you a little bit about what the AI sound chip is, and here you can see the two variants that I'm gonna use in these two projects. You have the AY-891X and the AY-891X. They're essentially the same chip, however one of them is obviously bigger than the other one and has more features, but besides that they're quite similar. If you take a look at the Wikipedia page for the AY-891X, you will find a lot of information about this chip, and it's a 3-voice programmable sound generator, or PSG, and it was designed by General Instruments already in 1978. It has 3 channels of sound with a frequency response that can produce almost all of the notes on a 88-key piano. The chip was used in a lot of arcade video games, and it's listed a lot of games where it was used, and also a lot of the microcomputers from back in the day, the Amstrad CPC, Color Genie, TK100, yes, I have that machine, MSX machines, and the ZX Spectrum. But that is the newer variants of the ZX Spectrum, not the original, which I'm gonna take a look at today. The difference between the two variants is essentially that the 8910 has 2 8-bit I/O ports, while the 8912 only has 1 8-bit I/O port. In practice, the difference means that the 8910 can essentially drive other hardware as well if you want to connect it up to, like, say, a joystick or other type of controls. In addition to generating sound, then that can be used for that as well. So let's build them then, but first I need to find all the parts, and yeah. I already went shopping. A lot of stuff here, and the easy part is finding like resistors and capacitors and regular 74LS logic chips and stuff like that. I needed a speaker, yeah, whatnot. But the hard part is the sound chips, which obviously no longer is being produced. You cannot buy them new, but I found on the internet, on eBay, I found 5 AY-891X. Hopefully they are real and not fakes. The 8910s were easy to find and quite cheap, but the 8912, which is this, was a bit harder to find and cost a lot more, so I only got one. So I hope this is working. If not, then I have some problem. And of course the PCB from PCBWay, and the minimum order from PCBWay is 5 PCBs, and that only costs $5 for 5 PCBs. So these 10 was a total of $10. I'm only gonna build one of each at this time. What I'm gonna do with the rest, I don't know. I actually got them delivered to my door within 3-4 days, all the way from China to Norway. Yeah, they look amazing. Yes. So this is all through hole components, so that should be easy to solder up. And the other one, different color. Yeah, looks just as nice. Alright then, let's start with this one, the purple one. It's using the 8912, which I only have one of. Yeah, apart from the regular electronic components, you also need a connector or a socket on the other side, so that you put this into your computer like this. Then it's time to gather the components I need, and it's clearly marked 4.7 microfarad, 1K resistor, 33K, but I'm still gonna refer to the bill of materials from the project file. Yeah, now I've been all over this PCB with my fat fingers, so clean it up a little bit before soldering. Place it into this holder. Makes it easier to solder. I'm gonna use sockets for the chips. I always do that, even if it's not strictly necessary, but it's a good idea in case you make a mistake and you need to replace the chip you have soldered. Yes, I'm gonna start with the sockets and then the rest of the components and then finish off with the connector. For me, it's not just about using the computers I have. I also like to build stuff. So that's why I love these projects. Even if they're not very advanced or anything, you learn a bit from it, you learn how things work, and you improve your soldering skills, stuff like that. Yes, time to start soldering. So to make them flush with the board completely, I just solder 2 corners, or you can solder in the middle if you want. Then I just push from the other side and heat up again, and it falls into place. Do that with the other ones too. Try not to hold the pin I'm heating up again, because then I'll burn my finger. Oh, okay. So now they should be all flat. Yeah, that went well. There's a lot of flux left behind because there's flux inside that solder. Then the rest of the components. It says here 1 nanofarad, and that's going to be a ceramic capacitor. Yeah, those small caps are often given in picofarad. This one is 1000 picofarad, and that is the same as 1 nanofarad. Can be a little bit confusing. It's not that important how you solder these hobby projects, if it electrically works, but I want to have it looking nice as well. I want to have the components straight and preferably in the same direction for resistors of same value and stuff like that. That's just me. $100 nanofarad, that should be 100,000 picofarad. Yeah, and again, this is labeled as 0.1 microfarad. So again, you have to do the calculation, and that's the same as 100 nanofarad. Sometimes I get In fact, I get a little bit confused myself, so I use an online calculator. You can simply ask AI too if you want. By the way, I bought all these components from DigiKey, which I usually use. Not that I want to promote them or anything, but they have always been fast in shipping and never any problems. And if you order for like 45 euros or something, you get free shipping. I probably mentioned that before. Try to get enough solder into the hole that it actually comes out on the other side. Yeah, it came out on the other side and around the component pin. Then we have a 4.7, and that's a regular electrolyte. It just says 4U7, but that's 4.7 microfarad. And it has a plus marking, and the long pin is the plus side. These are usually just hold on and bend the pins to the side and then solder them straight in. So did you get any snow yet? We had a lot of snow already, icy and slippery conditions. I put my winter tires on my car a long time ago. Then we have a 10 nanofarad and a 100 nanofarad. And up here we have another 4.7 and 100 microfarad there and there. And that's all the caps. So I'm going to solder in the rest and then I'll be back. Yes, now all the small components are in. I mixed up a couple of resistors. I had to resolder. I mixed the 3.3 ohm and 33K. So you really need to double check everything. Now the rest of the components, like the connector here, should go on the other side. So there's a volume potmeter, a button there, and the main connector. Yeah, and it's this one. And this too I found on DigiKey. Oh, no, that's not... Oh, have I done a mistake now? No. It's too big. What the hell? It's too big. Yeah, I have two of those. And I ordered the product that was listed. But it is too big. That's a bummer. What does that mean? That means I have to cut it or order another one and wait. Let's see if it actually fits the machine. Yeah, of course it doesn't. This contact would not fit if it's not cut. So here's a connector that actually do fit. Yeah, it needs to be open in the ends. Yes, and the bill of materials list actually says cut to 23 pins. So that means removing one pin on each side. I mean 2 pins, but one row on each side. Yeah, this is a picture, and you see it's been cut on both sides, and then it has a blocker there. That's not going to be easy to cut that very hard plastic contact. Yeah, I can just pull out the actual contact, so that makes it easier, obviously. I don't really like doing this kind of work inside here because it generates a lot of dust and yeah, smell, melting plastic. But let's see if we can do this. No, I'm not going to do it. It just spews out a lot of plastic particles. I'm going to try with this small metal saw here. Probably not very sharp, this saw. Yeah, seems to be working. I don't want to damage or destroy one of these connectors. I only have these two. Yes. Maybe I cut a little bit too close. I can see the pins from the outside, but yeah, they're going to be soldered in. Then the other side, I'm going to cut a little bit further out. Yeah, that's a mess, but it should work. Not completely straight either. I'm gonna file it down a little bit. Yeah, now it should work. Yeah, so I filed off the edges a little bit. I put some plastic there and some super glue to hold it in place, and then this should fit. Yeah, it's clearly marked, so nothing to worry about. Install the switch and the little 10K potential meter. So now I'm going to solder that, and then we're finished with the soldering. Yes, and I almost went ahead starting to solder the connector from the wrong side. Yeah, now it came much higher and more flush with the board. This is the switch. And finally the connector. Same there, I just tack down a couple of pins on each side. Then push. Yeah, you saw it jumped up there. A little bit long pins on this, so they all need to be cut. Oh, those were breached. Yeah, that fixed it. I go from the other side, it's better. Yeah, that looks good, I think. Now we're done with the soldering. I'm just gonna clean up this board, both sides, before I insert the chips. Remove all the flux. I just wash it with some alcohol first, then I take it down in the sink and wash it with some soap and water. Otherwise you get this layer of flux all over the board. Yeah, I cleaned it with alcohol and then soapy water and then more alcohol, but still I am struggling to get a good result on these kinds of PCBs. They always get a little bit of grayish a layer or something on. I'm not really sure what to use. Do you have any tips for how to clean these boards properly? Then just give me a comment under the video. Anyway, this should now fit into the machine. The only thing I'm worried about is after cutting the edges, the whole thing gets a little bit less stable and might break, you know, because of the pressure or the stress. Anyway, it needs some chips, and yeah, it needs a 132 74 LS 132. And that's if we get it the correct orientation, this 7402. That's this way too. Then of course we need the AY-891X chip, and that's the sound chip. What's actually cool with this is that if you have one of these cards, you could obviously make some software to do a lot of fancy stuff with this chip, sound wise. Hopefully it's a real chip and it's working. The last thing is the little amplifier, and there I couldn't really find the exact match of a chip to buy as new. It is supposed to have a LM380, but that was not for sale anymore on DigiKey, so I got a 384 and a 386. And I read a little bit, and I think the 384 should be compatible, so I'll try with that. Yes, the board is finished, but I noticed a small thing. Maybe you noticed it already too. There's a bridge there. After cutting all the pins for the connector, I just went over each of the solder joints. I think one of the cut-offs got stuck between and made a bridge. Yeah, no, it's good. So I'm a little bit eager to test it, but I'm gonna keep you in suspense for a little bit more. I'm gonna build the other board as well before I start testing. But fear not, I'm gonna be quicker with this. There's a little bit more soldering, but it's the same all over again. So I'm simply gonna just solder it up, and then I'll be back. And if something exciting happens, then I'll come back too. Yeah, there's a couple of differences. It's a bigger chip. It's a 40-pin chip, but besides that, yeah, it uses a LM386, a 7402 and a 7432. Just a small stop here. I started with the sockets, and I need a 4-pin socket, which I don't have. I very rarely use such small sockets. Smallest one is the 7 pins, but that's not a problem. You could either just remove the pins and just place it like this, but then it comes in the way of other components, so just snip it. Yeah. Yeah, it won't look good, but definitely works. So then we have a 4-pin socket. Yeah, the second card is finished too. The YC Mozart lives. It went alright. Some dirt there. Yeah, I'm just gonna prepare a couple of speakers. Already fixed one. I got a couple of different speakers. They need the two cards need different speakers with the records of the resistance of the speaker. However, this card has also a 3.5mm audio jack, which you can use. Yeah, let's see now if it actually fits. Yeah, that fits nicely. And you have the button and the volume pot meter on this side. Yeah, and I forgot to add the chips. That's a small LM386N amplifier. And that's it. Seems like this card exposes some lines from the computer, I/O lines out on the card, but that's not in use in this case. And again, thanks to my sponsor PCBWay for providing these. Alright, building the cards was fun, but it's the end result that counts, and that's testing them with a computer. So I'm simply just going to power on the machine, see if nothing bad happens. Yeah, the power is off, even if I inserted the power contact. And we need some software to test with. Yeah, nothing bad happened. Machine still works. Okay, so to program anything to this card and make it sound, you actually need to make some code in BASIC or machine code. But to do that, you actually need to know the AI chip and how it produces sound and how to set the various register and all that. But I'm not gonna dive into that, not now at least. But there are some programs you can use, and specifically with these cards. On the GitHub page of the projects you find some downloads. Just go to the Factor of Math GitHub and the repository for the Sinclair set XPSG, and you'll find the artifacts area, and I just download everything. Also under here there's a couple of basic test programs you can try out. Register test and test in BASIC for playing some tones. And inside the zip file I downloaded you find the various programs, and there's a tap file so that you don't have to type the basic programs yourself. You can load them from a memory card and a cassette emulator if you have such a thing. I have this one, the SVI CAS, it's very handy. It uses a SD card, and I'm just copying the files over to that, and then we can test. I hooked up an original power supply to the Spectrum because I need the other one to the SVI CAS, and it's kind of noisy. If you hear some background noise, it's from that. Yes, I'm gonna try to do this not too complicated and time consuming, but I copy the folder ZX Sound to the memory card and place the files there, and I'm now testing the HE. And here we have something. We have a AI-reg test.tap. We can load. Yes, it's load. Yeah, there it is. Okay, so that's some numbers, some bytes, but it seems to work. What's the program? It doesn't do much. It sets some variable and then it runs and calls some out command here and prints out the values. Yeah, so that probably means that the thing works. Let's see if we can play something. Let's try this AY test tap. All the other files are just text files and binary files. You can't really load those. Okay, I hear a sound. Yes, it's coming out from this little speaker. Quite loud. Yes. That's it. Yeah, probably this is another small programs. It sets the tone, leave register 1 at 0, point to register blah blah blah, 255. It was 200. Yes. But that's no fun. Let's load another program. It's called Minuets. The Minuets. And that's actually a program written in assembly because the assembly code is there too. That's a little bit longer program. Well, that wasn't much. It is actually a basic program, but it wouldn't do anything. Probably has some machine code embedded in it. Yeah, I don't know, I found another program called Minuets. The other one was Minuets Basic. This one seems a little bit longer. Yes, okay, so here we have something. I actually saw this on the 8-bit show and tell channel, but yeah, what was it? You can make it play some random music, I think. Okay, you throw a dice. Yeah. It works. It's quite much lower now, but you have the volume pot. It is clearly 3 voices in the audio. Yes, it works. You can hear it's multiple voices. Well, sorry if this damages your ears. Yes, I'm sorry this isn't more exciting, but yeah, it shows the capabilities if you have such a card, but of course you need some software to use it, and there's a limitation there. Let's try the other card, see if it actually works with the same program. And I'm going to use the other speaker, which I think was dedicated for this one. And does it work? Yeah, I heard a little click in the speaker, so let's load the same. Yeah, and I'm not sure if this program will work with this card, we'll see. And this uses the AY-891X. So let's try 3 then. Yeah, it does. Smaller speaker, just as noisy. I could of course hook it up to capture the audio, but I'm not going to do that. It's kind of neat animations for the dice. I guess if you keep tossing them, you end up with some random music, and that's maybe the point. Yes, no, something happened. Yeah, manuscript, yes. Alright, so now it draws something here, not particularly fast. Yeah, it's a note sheet. I guess this is drawn in BASIC, I don't know. It was machine code program 2 here. So I was googling a little bit around to see if I could find something else that can use these sound cards, but I didn't find anything particularly, so I don't know. I don't know if you have a game that supports the AY chip, if it actually will use this. Maybe we should try. So I'm just testing this Cybernoid game, which supposedly should have support for the AY sound chip on the original ZX Spectrum. I mean, the ones that has it. But there's no sound from these sound cards. I tested both, and I guess that wouldn't work. Well, I was almost certain that it wouldn't work, because probably on the original Spectrum there's other registers in use for controlling the sound chip. Yeah, that sound comes from the Spectrum itself, not the sound cards. Before I conclude this video, let's take a quick look at how to program these cards, or I/O in general. The ZX Spectrum Basic has the out and in commands. Unfortunately, those are missing on the ZX80 and ZX81 Basic. And these are the commands used to control the CPU and what it's supposed to send out and read in from the I/O ports on the CPU. And these are the same ports that are connected via the expansion port to these cards. And one of the cards has the small chip with only one I/O port, and the other one has both. So here's the example program that I showed you before, and it is for the ZX Sound card with only one I/O port, the small chip, and it uses an address, or it's actually a register A, that's for the address register, and register O, that's for the data register on this card. So 159 obviously corresponds to certain bits on the I/O port, which is 8 bits. Same with the RO, it corresponds to certain bits set to the data register via the I/O port. And for this card it's 159 and 223. For the other card it's different. And here it uses the out command to set the 0 first on the register, on the address register. That selects channel A register, and then it sets 200 on the data register, and that sets the tone period to 200. So remember, these are bits that are going out to the actual AY chip. And then there's something more going on here, setting more register 8, point to the register 8. Then it sends the value 10 to that to set the volume to 10. And then it points to register 7, and then it sends 254 to switch on channel A. And that makes a sound, as we have heard, and then it just waits for enter. And when you have pressed enter, it sets 255 again to the data register, and that turns it off. So if we run this, beep. So that means we can change the tone period, for example, to something else. If we set it to 100, for example, we should get a lower tone. No, it's a higher tone, so it's the opposite. So remember that you're sending bytes, but it's bit patterns to control the various registers in the chip. So to do the same on the ZX80 or 81, you need to use machine code, since it doesn't have any in and out commands. The in command reads, as I said, from the I/O port, but to learn how to program this chip's features and fully control it and make music and stuff and sound effects, yeah, there's a lot of stuff you need to learn, and you can take a look at the data sheet for the chip to learn more about that. There's probably books and lots of articles as well. Yeah, so that was it for this video. I tried to look around to see if I could find any software or music or anything for these projects, but I couldn't find anything. So yeah, what's the purpose of these then? Well, it's purely for experimentation, and yeah, I thought it was a fun build, and always fun to use these old machines in different ways. Hope you enjoyed this video, and don't forget to check out my Christmas video. Thanks a lot for watching. Don't forget to subscribe and like, and special thanks to my patrons that are supporting me over there. See you. Bye bye.